In this short video, I'd like to walk through this idea of finding the area of a soup can label. And then what we'll do is connect that to the shell method of finding the volume of a solid of revolution. To start with, you'll see here my sketch. I don't know if I can really call it a sketch, but my attempt at a sketch of a soup can. And then you see the orange label on the outside of it. Now, if I made a cut where you see this blue line, if I made a cut here, sliced that label off and unwound it, do you see that what we would get is the shape of a rectangle? And the area of a rectangle is going to be the base times the height. What you want to look at then next is how could we describe the dimensions, because how could we describe the base? How could we describe the height? The base of this rectangle is going to be the circumference. Do you see that connection there? That this base, when we unwrap it, is going to be the circumference of our can. So the circumference formula is 2 times pi times radius. So the base is circumference 2 pi radius. The height is going to be the height of so the height of the rectangle is the height of the can. You don't really see that perfectly here on my picture because it looks like the label is starting just below the can, but that's just poor artsmanship. If you could picture the true label, it would go all the way to the top of the can, right? So the height is then the height of the can, f of x. Oh, I scratched it out. So f of x. Is that height of the rectangle. That gives us an area of 2 pi radius times f of x. If I let the radius of this can be represented by x, that would be 2 pi x times f of x. Let's see how that connects to our shell. You can see from the shell that what I've done is I've taken this shell, I could think of it as a koozie, right? I've sliced it and peeled it open. The distance around is a 2 times pi times the radius. Now the actual radius we're going to use, for radius we're going to use x, so 2 pi x. The height is going to be the difference between the two functions that we're revolving. And you see that the width of this, let me use the green pen, the width of this foamy thing is going to be dx. What that gives us is a volume of 2 pi x times the height, f of x, times dx. We could write that, simplify that, as bring the 2 pi out, integrate from a to b, x, f of x, dx, where f of x is the difference between the two functions that we're revolving around whatever given axis, and this is an x, a nice solid x, or a y, based on what direction we were revolving, if we're revolving around an axis. When we go around a line other than the axis, it might be the constant plus or minus the x. And that wraps it up. I hope that that helps explain that just a little bit better, the connection between a soup can and the area of the soup can label, and then how that connects to the shell method.